Morning, Europe, and hello, everyone. I'm Roderick. I'm happy to be here today, and I hope you're all having a great day and then healthy so far, no matter what location or which time zone you're currently in. I'm going to share some of my experience related to building a large scale of the web application today. In this session, if you're about to start a new project or trying to scale up your existing web app, I believe this topic will be really helpful for you. A little bit about myself. I'm a product engineer architect based in San Francisco Bay Area. I've been in the tech industry for more than 10 years, including some large corporate, startup, and consulting service. I enjoy a lot of building products on the web platform, as well as architecting the web app to be high performant and able to easily scale up. Web application can be provided the same delightful user experience, in my opinion, just like native applications. Also with the benefit of highly shareable or discoverable content. Products I build, including like information portals, news, weather, dashboard, and the most recently is the Tinder dating web app. Before we start, let's talk about what is skill when we talk about building a web app. First of all, when we talk about scale, it means that your app could handle a large scale of the user traffic, as well as handling sudden spike from events. Depending on the nature of your web app, some app mostly will have the regular traffic during the week, but on the weekend, it could increase the traffic, or some could spike 20x during a specific event like breaking news. Your service should be able to provide a stable level of the service all the time, or at least have a decent degrading mechanisms so your core functionality is not affected during the sudden spike of the traffic. And the other aspect of scaling when we talk about is how easily for you to roll out all your feature to more audience or markets. Let's say if we complete one feature of your target audience of bucket testing, how fast is it for you to roll out the same functionality or features to more audience? For instance, if your app is able to easily provide different language translation, CSS styling, or configurations based on the market easily. And of course, when we talk about scaling, we also mean that you could adopt similar development cycle to different features which could be easily replicate the process and deploy the feature easily. On the other aspect, if you want to progressively enhance your code base, for example, adding a performance enhancement to your image loading strategy, how easily is it for you to adopt the enhancement to all of your code base without a massive code refactor? It could include things like tooling, standardizations, logic abstraction, and some of the best practices. Finally, I believe like everyone here have similar experience. Your code is maintainable and highly performant when you're just developed by yourself or within a very small team. However, the code becomes really complicated and the new features added in, there are more team members joining, and then your code is suddenly start to be really hard to manage. Everyone programs differently, and if the code base is already have great code complexity, which is not easily to understand, most of us, when we develop in code base you're not familiar with, we will start to crave out conditional logic to bypass or cloning existing logic to avoid breaking changes of the existing business logic. Then more tech debt is actually added along the way when the feature is built. So without the good fundamentals or infrastructure, adding new features or code is more like adding Band-Aid or ad hoc logic, and eventually will slow down the development time in the future. The above I just mentioned are all critical when we talk about building a large scale of the web applications. So you might ask me about what framework or toolchain will be the best for us to building a large scale of the web app. In my talk today, I'm mainly focused on using React as an example. However, the methodology I mentioned today will be easily to adopt to any of the JavaScript framework or infrastructure, or even just vanilla JavaScript. The front-end ecosystem has progressively greatly in recent years. For the traditional way of just server-side rendering, have the handling the markup like PHP or other server-side languages, and then on client-side JavaScript in charge of interaction logic, to the isomorphic app, which means like using the similar rendering logic in server-side and client-side. And most recently, we have a serverless solution or full client-side single web application solutions. If we use React as an example, the recent framework like Create React App, Next.js, Gatsby.js, or some like component-based focus library, they're all solving like different use cases. Almost all the toolchain above provide zero configuration setup by default, because we all know like we are, not all of us have the deep knowledge about bundling or like JS compiler. Create React App provides the easiest way for you to start an application without any configurations, because it is also maintained by the Facebook core team. It becomes a really good playground for testing like new React features or got good React team support. Gatsby.js, for example, rendering most of all the dynamic page in build time and storing cache, which fulfills most of the use case of static content, or we can call it predictable data. It is really nice architecture as all of your content will be pre-built and stored on the edge, which already optimized for user around the world. Next.js focus more on pre-rendering pages and has good support on server-side rendering. So it will be really optimized for things like search index, social sharing, and more things that you need initial server-side rendering complete. Most of all the framework here will be able to scale up your app in a certain ways, depends on how your web app is built and what use case you're optimized for. The talk today, we're not framework specific. We will be focused on the level of abstraction on top of all this framework, which could be make your app more extendable and maintainable. You might ask me, why do we need abstraction and what kind of abstraction do we need here? The benefit of abstraction could be hard to notice when you start or just have a really small team. More importantly, if you might feel like it's not straightforward to abstract, comparing if you just implement everything in the component level. It is true that sometimes overly abstraction can make over-engineer and create high learning curve for new members. So it is really important for us to always strike a balance. I would suggest that you always start to think that, or in a preparation of high-level abstraction, when you find out you're starting duplicating a lot of UI logic, and then start to having a lot of condition logic for a certain use case. It is important to show some example here so you can have some idea about the benefit of abstractions. The first and the most common practice is to build a common component regardless of any framework you're building. If you're using React now, React is already a component-based system. So by nature, you're already building a shareable component where you start using React. However, this is also one of the areas that's very easily to overlook or make your code really complicated if you're not designed properly. I'll share some common component practices that you can improve your app structure and make it easily to manage your code base. The common components by purpose, we can probably divide into like a couple categories. I will mention about styling, functionality, and logic abstractions. Those are not really mutually exclusive. Some components provide multiple purpose. Styling, sharing is probably the most common reason that you're trying to build a common component. In this topic, it is critical to mention about design systems. Design system is a contract, I would say, within the team that to access function how the web app style should be logically built, why you need a design system. Thinking of like design system just like a coding style rules. Let's say if we have a button component, common component could provide the same look and feels when you're using the UI button across the code base. So you will have a consistent look. In React, there are multiple ways we can handling styling. Most commonly used is passing by props or using CSS in JS or like CSS override or using React context such as theming. You might not having a design system from start, but it will become really problematic when your team is scaling up and more feature added. Some example is like the component you build is just slightly look different from this page to the other pages. This will create like a tag that you will be very hard for you to share the same component across different pages. Most of us experience the UI component style start to diverse when there's a new designer come in or their feature comes in without using the same design system language. For example, there will be slightly different color hex code, slightly different border radius or padding, which makes the simple common components start to handle a different UI context. Like if this button putting on login page just looks slightly different in other pages, and it will become really hard for us to pick up a style combination when we have more options to pass in. So this kind of defeats the purpose of building a shareable component because the component is just handling too much. What is the downside of not having design system? As I mentioned, first is your components handles including like unnecessary styling just for very small variants, which could be unnecessary. In an ideal world, your common component shouldn't know what context is currently in. For example, it's putting in login page or putting in sign up page or a checkout form. The UI context is tightly coupled with your business logic. So if your component will become like very hard to understand and used without the knowledge of the use case the component is currently in. It could result two scenarios when your component is too hard to extend. One is we will start to fork the components and keep the adding keep new conditional logic inside, which creates really a lot of code complexity here. Let's say if we have a revamp of your web app, it might be very hard for you to test out all the combination because you just have too many conditional logic in your common components. And your app will always look slightly different with potentially increased CSS or JavaScript size, hurting your rendering performance, or just not look well polished. So what can we do here? In terms of sharing the CSS styling, I would say be very cautious and picky about the CSS you're going to add. Thinking of that, you will have a really strict budget of adding new style. Ask the team that, is this small variant really necessary to be introduced, or we can reuse the existing color, existing system we have. If this style used in this style is using the correct context as same as other pages component, or it is a really unique that you has to be using this different styling. Collaborate and document how you build and use the common components. So the next thing we're looking here is about functionalities. For example, if you have an image loading components, we handle some of the image loading optimization, such as preloading, lazy loading, or image placeholder, or error handling. It is very good practice for you to start building common components. However, it is also one of the easiest place you have incorrect abstractions. Common mistake, including like you're coupling your business logic into a shareable component. For example, if you have a feature flag to control by a props in React, you could name it related to the feature, not with the context. For example, if you have a component that can display an optional footer header, a proper flag should be something like show footer, show header, rather than is login page or is in certain bucket. The other common mistake that overly abstract the logic to a very low level components. For example, like building a component just for one HTML tag or like H2, H3 HTML tag, and it is easily to style or couple with some business logic. Overly abstraction will make low-level component very hard to use by everyone because no one knows how to assemble the same logic, and the same assembly logic will be duplicated in different places a lot of times. The last part for here is to avoid adding ad hoc logic for certain use cases. When you are about to add an if-else condition, thinking of that, you're adding an exception to a generic components, and everyone using this component will need to including your conditional logic, regardless if it's running or not. Keep your component separate with the business logic. Create a container of the parent component which handle this business logic, so your component will be pure enough to be shared. Last part of the abstraction, it is the logic abstraction. It is easily to share some steps or common logic when we use React hooks or like some utils function. Hook in React can make it abstract logic become mostly black box to your main logic flow. So your UI component will be much cleaner and compared to a lot of inline function. And so for new people that is writing your code in this code base will be really easy to read the main flow or what the functionality of your logic, your component is doing without knowing a lot of details inside implementation details in the different conditional logic. So we just mentioned about like different abstraction layer. So there's one common thing example we can show here is instrumentation. So instrumentation is something like adding tracking for performance or business logic or some sending a beacon to when user interact with some UI components. So this part is getting a little bit tricky and very easy for you to make the already common component become very complicated because it starts adding a lot of business logic here and really hard to share about to separate the logic from your business logic and your UI components. Let's say we have a UI button and we want to add the instrumentation when user click it. Assuming we're using Google Analytics, the common components already have like an OnClick function available. So how should we send an OnClick beacon? The most or easily straightforward thing is directly add the instrumentation in the handler logic, like OnClick here, and let's just call it a day. The problem is the component become tightly coupled with the instrumentation. If the same UI component is placed in other parents, the instrumentation will be different, and some people might start to duplicate the same UI logic just to handle different instrumentation values, or they will have an if-else condition to switch off all the instrumentation logic. A better way is move up the instrumentation in the parent component and pass down as a callback function. So yes, it is somewhat abstract the logic to the container to make the single component reusable. Do we need another level of the abstraction? It depends. The solution keep your common component clean, but not necessarily solve the issue when your instrumentation logic is isolated. And more likely, you will always need a wrapper component to provide the instrumentation metadata. Some other will consider like why we need an abstraction instrumentation logic here. Let's say if we decide we want to add another tracking system in our web app, like Facebook Pixel or any other tracking system, or if you want to deprecate one tracking system more commonly or send up your instrumentation beacon only after user consent to share the data for GDPR or any related privacy regulations, what you're going to need to do is go through all your code base and modify the parent's component logic and it will be highly expensive task for you to execute when you have a large code base, and not to mention it will be very error prone. One solution here we could use is the app level beacon handling. You will have a top level of the handler of your component, and we will send out the beacon when you should interact. The component will not really aware of which tracking system you are using. It basically just dispatch something saying like, oh, I need to send a beacon with a standardized payload. And on your top layer handler will know that, oh, if I got this listener, even either using like observer or even emitter or something like that, and then we will, based on the action, doing a corresponding beacon sending. So in this case, the tracking system will be separate from your UI component, and your real component just saying, providing the meta that for the payload of different tracking system, that this is a standard payload and I'm being clicked, so you can send out the payload if you need. This is an example of the high level event handler. So we have a click. So when I receive the click event, I will send out in GA in this example, and then with the category click, label, and different actions. What's even better if you can you leverage like React context. So in assigning a different event value from the parent, so the same child of the shared component will be able to inherit the value from the parent. So your beacon, for example, you have a button placing in parent A, and you have the same button placed in the parent 2. And these two common components, because of the inheritance of the hierarchy, you'll be able to send out different beacon based on the tree that you're having here. So your component will be identically, the payload will be the same, but the event is sending out will be aware of which context is currently placing. Last part I'm going to share here is about routing. Routing is one of the most critical part for single web applications. It handles like client-side navigation and page rendering logic. Let's use React Router as an example. The most basic code structure to have is to have a switch component at the top layer and handle component by route. You will soon develop a route-based component, and this structure makes it very easy to understand from the top layer of your main purpose of each route. What's even better here is that you can support route level code splitting easily. In this example here, we are using React Lazy to dynamically load the chunk when the page navigates to the route. Dynamic import can be used in different frameworks as well, as long as your bundling system is supported. So this is not really React specific. Do we need an abstraction here? Some common use cases, what if we need to handle like page animations or some common on-enter actions that you want to assign the meta tag to each route? Where is the best place for you to put these informations? Obviously, the most straightforward place is to directly put inside each route on the route component level. In our example here, we will be putting inside the component like about, user, and home. The downside of this approach is your route level components start to be aware of which route path is currently in. As we mentioned before, in the common component session, your child component should be unidirectional and not to be context aware. If our users component in this example here is shared by different routes, we start to complicate the component logic that you need to have conditional logic handling if it is placed in different routes. What could we do to improve is to move to a centralized route config. Standardize how your layout and the route is rendered. For example, we could provide the meta title in each route config, or even provide animation style or enter and exit. Perhaps you can have your page in one column layout, or some is in 2 columns. We could also standardize it and just provide the slot for you to read from the configurations. Some benefit of that is really clean abstractions and create very clean high-level app structure, and easily to progressively enhance your layout logic, such as adding a preload, prefetch to your next route, adding animation or enter exit. You can even swap out all the routing library if you decide to change other client-side history management strategies without touching your component code. That will be easily to migrate and test. One common example here is to add a preload logic. Preload is like when before you enter this page, we will load this bundle so user navigate will be faster. Let's say we have a higher order components that basically wrap your current component with React Lazy and Suspense. If you're not familiar with React Suspense, it's basically a conditional logic that helps you to hold the loading states until the child promise is resolved. React Lazy is utilize the JavaScript dynamic loading and to be able to load the component in the separate chunk. The example here is we will create a dynamic chunk components and only load the chunk when we navigate to the page. However, as the loading is separate chunk and require network fetching, members might see a delay when you navigate to the page before the chunk finish loading, especially for slow network. What can we do here is to easily add a preload function, and then we could invoke some common user interactions, such as when mouse hover a link or when the link is within the viewport. We can now and then call a function that just preload the chunk in advance, and such enhancement will not change any of your existing route architecture and could be easily rolled out to all of your pages. What we can even do better, for example, here is to preload the assets only on the browser idle time. This is to prevent some UI jankiness caused by high CPU usage. We can just wrap the preload function with request idle callback here. Then we can complete another progressive enhancement. Can we even do more? Sometimes, if the network is really slow, preloading will occupy the network condition and block some of your important resource on the page. Preloading should be only optional and low priority. We can then utilize a new browser API called Network Information API, which tell you that your current network condition and decide if you want to opt in preloading routes. There are much more we can do, such as honoring if user is in data saving mode and don't aggressively preload the route. And all this app level optimization could be isolated and adopt easily if you have a good abstractions. So to recap, some benefit of centralized architecture is to have clear logic isolations, a standardization of your rendering logic, and you will be easily to have or add new progressive enhancements. One thing to mention is here, although my talk today is start from UI component abstraction, in reality, you should always start from high-level abstraction first, preparing a web architecture and extendable to one of the most critical things in terms of scaling up your web app. So thank you for listening today. If you have any question, please reach me out. And I'm happy to be here and also learn your experience of building large scale of the web applications.